Hi guys, today we're going to be looking at Ohm's Law again. So I talked about it in the last lesson, and in the last lesson I gave you a strange looking triangle with letters inside of it. So the one thing about laws is they look kind of complicated when we first see them, but hopefully after this lesson today you'll feel really comfortable about calculating missing pieces of the Ohm's triangle. So just to remind us, let's draw the triangle again. So at the top of the triangle, we will have V, and in the bottom left-hand side we have I, and in the bottom right, R. So let's just remind ourselves what these letters stand for. So V, hopefully the easiest, stands for voltage. Remember, this is the amount of power coming out from a battery or a socket, the amount of pressure that can be sent through the circuit, essentially. I was a weird one, but it's current. Current is like the flow of electricity going through the circuit. And then resistance, R. This is a little part of the circuit that we can add to reduce the flow rate or the current. So that might be useful if you don't want to send all the voltage or the power to a particular device. Okay, you've seen that if you've had a power cut and everything kind of blows, you can blow fuses, you can blow circuits. So these little resistors allow us to control the flow of electricity around a particular circuit. So we're going to look at some really basic examples today. I'd encourage you to write this along in your workbook as well. And we're going to do a little table and a graph by the end. But I want to stress that when you see this initially, I know it doesn't look fantastic, but by the end of this, it makes sense. It's really simple algebra, really. So the three components: voltage, current, and resistance. And how do we measure voltage? Well, we measure voltage in volts. And the unit we use is a V, which is nice and useful. Current, we measure that in amps. Amperes to be precise. And we sometimes you should use the word amps. It's not too long. Now resistance is measured in ohms, who the law is named after, Georg Ohms. And it's measured in ohms. But the unit, the symbol that we use after resistance is this symbol here. Now this is the omega, and it's a symbol that we use instead of using OH or M. So some people might ask, why don't you just use OH or OHM to talk about resistance? The reason we don't use that is we'd run into problems quite quickly. So imagine we had a resistance of 20 ohms over here, and I used O, for example. That doesn't look great, okay? It could be 200, doesn't look like 20 ohms. And if I add the H in there, okay, that could be 200 hours, for example. So we don't use OH because it's too close to what the number could be, and it could actually make our data look a bit muddled up. So instead of that, we use the symbol here. Okay, so it's very hard to confuse the omega symbol with anything else. So we know that that is 20 ohms. It has a resistance of 20 ohms. Okay, so if we're clear with that, let's go and do some simple examples. So, in the last lesson, I drew a simple circuit. So we're going to do a simple circuit together. So the way we draw a battery is this kind of long line followed by a shorter line, and then we have our wires. We're going to have a resistor in here, often drawn as a kind of squiggly line, and then we complete the circuit. Now it's up to you, you can put the plus or minus. This is where the battery is, so whenever you've added a battery into something you can put the plus or the minus sign, but this is our simple circuit. And we're going to do some very simple calculations using this triangle to work out parts of the circuit where numbers might be missing. Okay, so we're going to do a really, really simple example. imagine we have a battery in here that has 10 volts. Okay, so we have a battery that has 10 volts. And say we know that the current going around this circuit, so I, the current, remember I over here, equals 0.2. Okay, so if that is 0.2, how are we going to calculate what the resistance is over here, R? Well, if we look at our triangle, if I rub out these letters and replace them with the numbers, so I is 0.2, volts is 10, then if I write this out another way, R equals 10 over 0.2. Okay, R equals 10 over 0.2. Now if that is the case, 10 over 0.2, what is the resistance going to be? So maybe give you a second to calculate that. What is the resistance going to be? 10 over 0.2, the resistance is going to be 50 ohms. So you may want to check that. It should be 50 ohms. Okay, I hope that makes sense so far. So let's just try that again with looking at changing these numbers. So say we change the numbers here. Let's just rub this out. Okay, let's just put V and I in here again, just so we know what we're talking about. So let's change the numbers again. We're going to do 10 volts again as our battery. But let's change the current to 0.5. So we're going to do the same thing again. I'm going to replace these letters. So you have 10 volts, 0.5. So why am I doing R equals 10 divided by 0.5? The answer is because V is up the top here, and if you look at this triangle, 10 over 0.5 equals R. And I'll do more examples to explain how this works again. But R equals 10 over 0.5, so I'll give you, if you want to pause that and give me an attempt, what do you think 10 divided by 0.5 is? You have a calculator, try it on your phone. Okay. 10 divided by 0.5 should give you 20 ohms. Okay, so far so good, hopefully. Now what we're going to do, imagine you know that your resistor, let's go for the first example that we looked at. We know that our resistor is 50 ohms. Let's drop this out. Okay, so we know what V is. That hasn't changed, that's 10 volts. Now we know what R is. R equals 50. So how are we going to calculate I? Well, if we do our little Ohms triangle, V, I, sorry it's looking a bit messy. So how do we calculate I? Well, I is going to equal V over R. Okay, we just substitute these numbers in. I is going to equal 10 over 50. 10 over 50. I'll give you a second if you want to calculate that. What is 10 divided by 50? Let me pause that and try again. But if you see what we did to the first one, I equals 0.2 amps. And that is the answer we got for the first question. The first question we didn't know the resistance, but we knew that there was 10 volts, I equaled 0.2, therefore we had 50 resistance. Okay, let's try the last one that we haven't looked at yet. Let's just rub this out. Let's say we don't know what V is, okay? Let's rub out V. So we still have our triangle here, V equals I over R, okay? So we're going to do a different example, and we're going to look at how do we calculate the volts from this example here. So say that we have this resistor, and we know the resistor has a resistance of 10 ohms. Here's V over here. We know that the current, so R equals 10 ohms. We know that the current in our example here is 2 amps. So I equals 2. So this is going to be slightly different from the other ones we've looked at. But to calculate V equals I times R. Because they're sitting together at the base of this triangle, we times I times R together to tell us how many volts we have. So if I just substitute the numbers we have, volts equals 2 times 10. The volts we have in this circuit must be 20 volts. V equals 20. So it's really quite simple. We're using simple examples, but we don't really need to be much more complicated than that for just to show how this law works. So we're going to do one more example, a bigger example that I want you guys to maybe draw a table in your books. So what have we got here? Let me just rub this out a moment. Okay, so I'm going to do a very small circuit over here. Let's say we know the resistor we're going to use is 10. We've got a resistor that is 10 ohms. Now we're not going to change that throughout the entire part of this part of the lesson, okay? The resistor is not going to change. What we're going to change is the voltage. Okay, we're going to change the voltage from 0 to 5 to 10 to 15 to 20, 25, 30, and then we're going to see what that's going to do to the current. Now intuitively, if you increase the voltage and the resistor stays the same, what you should expect to see is the current would increase. Okay, the flow of electrons going around the circuit should increase. Okay, so hopefully that's what we see. So what we're going to do, I want you to do this in your little workbook. We're going to do a table. You're going to use a ruler, so it's going to be cleaner than mine. Mine might be a little bit wobbly. But you're going to put here volts. Okay? And then you're going to put current. Okay? So our resistor R equals 10 the whole way through this. R is always going to equal 10. Our volts are is the variable that we're going to change every time. So let's start off with 5 volts. Let's do a little triangle up here again. Okay, V over I R. We know R is going to be 10, and I've just told you that volts is going to be 5. So if I draw this over here, what is I going to be? What is our current going to be? I. So I is going to equal V divided by R. So all I need to do now is substitute in the numbers that I have. So I is going to equal, our volts are 5. 5 divided by 10. If you have a calculator handy, do that for me. 5 divided by 10 should give you I equals 0.5. Okay, our current is 0.5. Okay, let's do that again. Let's just go up in volts. We're changing the battery from 5 volts now to 10 volts. If our battery is now 10 volts, I is still equal V divided by R. I is equal then, our volts are 10, our resistance is not changing, so 10 over 10, 10 divided by 10 should give us 1. Okay, so if you look at this table, I know we've only got 2 data points, but as we increase the voltage, it looks like our current is beginning to increase as well. So let's keep going with that. Let's do 15. Okay, so we're still using the triangle. I equals V over R. That doesn't change. I then equals 15 over 10. 15 divided by 10, 1.5. Okay? So if we do this, exact same thing, just keep increasing the voltage, we're seeing a little pattern starting to emerge here, but we'll do it again. So I equals V over R, I equals 20 divided by 10. The current then hopefully should be 2. Change this, increasing it again, 25. Our answer, I'm hoping you can see the pattern now, but you can do the calculation. So the calculation would be I equals V over R, I equals 25 over 10, 2.5. 30 is going to be 3. Okay, so I want you to check that out and do it yourself as well. Don't just assume that I've got it correct. And then what I want us to do, we're going to graph this out. We're going to put it into a little graph. Okay, so you're going to be much smarter than me. You're going to use a ruler. I don't have a ruler, unfortunately, on my whiteboard at the moment. Plus, I don't have grids, so I can't be as accurate. I'll try my best. So, how are we going to graph this data that we've just collected in this table? Well, we need to have our x and y axis. So remember, let's do here. So we have our y axis and we have our x axis. Okay. What do we know? How do we decide what goes where? Well, we know that the x axis here and the y axis is here. On the x axis, we always put the independent variable. So the thing that I'm changing all the time. What I was changing all the time is the voltage. So the volts are going to go across the x-axis. We're going to start with 0 volts. We didn't have that. Then went up to 5, 10, 15, 20, 25, 30. Okay, so that's my graph there. So these are volts. Remember, you need to label that. So this is volts, voltage, and then I put the units as a V. So that means our y-axis, the one that is going vertically, is going to be what we call the dependent variable, the variable that depends on what is going on down here. So this current was changing because I was changing this variable. So this variable current is dependent on this variable voltage. Okay. So let's see, what was our highest number? 3. So we go 0, 0.5, 1, 1.5, 2, 2.5, 3. So looking at this now, it looks a bit squint, but that's okay. Remember, we always need to label our axes. So this is current. That is measured in amps. So now all I need to do is read off my data. So I've got this little thing here. I might try and use this. Should have used that at the start. So we're going to now plot our data. Okay, so the data we have in this table, we're going to plot it onto this little graph. So at 5 volts, our current was 0.5. 10 volts, our current is 1. For 15 volts, our current was 1.5. For 20 volts, our current was 2. There. 25, it was 2.5. And for 30, it was 3. Okay, so that's not ideal. You guys are obviously going to do a ruler and use grid paper, but you should have something that looks like this. If we draw a line between it all, which again might not look too good on here, should be a straight line. Okay. Okay, not the best graph I've ever drawn in my life, but you get the gist of it, okay? As we increase the voltage, we see this positive correlation with the current, which makes sense. So as we increase the amount of power that's in the circuit, we're increasing the flow of the electrons in there, okay? So you may want to try and do this using different calculations, which would be cool, but you should always see this kind of trend, and that's because of Ohm's law. So the whole point of a law is, it doesn't describe why something happens, it just describes how it happens, and when you increase the voltage by a certain amount, you increase the current by a certain amount if you know the resistance, okay? So I hope that makes sense. Please fill this in your own workbooks. If you have any questions, feel free to ask me.